My birthday is yeah.
All right, guys, let's get started. So today we're going to continue with RSA. We're going to do something pretty fun today. Spent a little bit preparing this. It's like a quiz, of course. And so the goal will be to crack RSA, right? So it should be a fun one. This is actually practice for the practical exam, right? So, some of it'll be like this. So obviously a little bit more complex and elaborate, but we're going to do an example of how to crack RSA. Not with the quantum computer today. Today, we're just going to use something called FactorDB. FactorDB is just a website, factordb.com. And basically, you're going to learn the process. So I'll go over again the RSA concepts, just kind of the algorithm, give you an idea as a refresher. And then keep in mind, I will give you a cipher and you need to break it. You'll be using the two Python scripts that I provided to you already, the toy one, toy RSA, and then the more complex RSA one. Okay. So the more complex one takes things in a specific format, if you think about it, right? So it's more formal, so it creates things. So that will be useful like when we have files. But in this case, I just want you to take out a sheet of paper and write the numbers on it. So basically then for that, you'll have to use both scripts to break it. Okay. And I'll provide some hints. Does that make sense? So we'll go over the basic concept today. I'll start with how to crack RSA is the title, basically. And then after that, I'll do the algorithm itself again, and then we'll start going through we'll use the virtual machine kind of to illustrate how that would work. Got it? All right. Yeah. And then from here, we'll do several examples of this on how to break RSA. All right. So I believe it's recording and I run this. So I'm going to use a whiteboard. So remember, I think we're on week 9 right now, I believe, week 9. And the practical and the next exam will be on week 12, in about 3 weeks. Okay. All right. So we have a whiteboard here. Pencil works. Okay. Run. All right, so how to break RSA. Break. Break RSA. Okay. So you know what RSA is. We've already gone over the lecture several times. You know how the algorithm works. You have two Python scripts plus PyCryptoDome. So you have quite a bit. And a lot of these resources will be needed for the practical exam, as I will just encrypt things, in various ways. All right, so the key. So let's kind of think about it. So the idea is something called factorization. That's basically the main approach to try to break factorization. So in RSA, we have a public key, right? So we have the public key, which is going to look like this. So we have E, comma, N, right? And then you have the private key, which is D, comma. Right. And we know that N is actually made up of P and Q, P comma Q. So these two values are also stored. So the private key, which is the D exponent, the N exponent. So these two values make up the private key. You're going to keep those secret, but you also, for convenience, will keep P and Q. If you have P and Q, you're basically able to break the whole of RSA. All right, so now what is factorization? So the idea now is, how do we break RSA? Let's create a new page here. Okay, so the technique that has been tried quite a bit and it works, it just takes a long time for really large numbers. And that's why we need large numbers. It's something called factorization. Okay. All right. And so basically the example of this would be, you have the number 6. So if you factorize this number, this would be 2. This would be 2. And this would be 3. Okay. So basically you have 2 times 3 equals 6, right? And that's the same idea of what you did with n. You know that, they're prime numbers, so you really can't factorize those. Prime numbers are just going to be 1 and themselves, basically, right? So the idea is that if you have P and Q, computing n is really easy, right? But if you have n, it is not easy to find that P and Q, given that that is going to be really large. So usually, I mean, you can come up with algorithms, techniques, whatever you want to do to come up with these numbers. In our scenario for this class, the way to factorize things, I'm not going to ask you to do it by hand. Instead, you're going to use either FactorDB. I think it's might be uppercase. db.com, which I'll show you how to use. Is very straightforward. Or we're going to use a quantum computer. And by that, I mean, obviously, a Python library, right? Simulating a quantum computer. There are algorithms designed for this, such as Shor's algorithm. So that's somebody that understands how quantum computers work and then basically created an algorithm that would do just that, right? So cracking, this is something that quantum computers are good for, right? So it has been found that they can do this effectively. All right, so I've motivated this quite a bit, and I gave you an article. So factors are the numbers you multiply together to get another number. That's basically the principle here, okay? So what are the prime factors of 12, for instance? So if we look at a bigger number here, what are the prime factors of 12? So in this case, you would do something like 12. Oops. 12 and then divided by 2. And that's going to be 6. Right? And then 6 divided by 2. And that's going to be 3. Okay? So basically then you have 2 times 2 times 3 equal to. And that's basically the approach. And you can keep doing that. I'm not going to do that further, but obviously as the numbers get big, the whole illustration here is, okay, let's do 48. That becomes, bigger and bigger and bigger. All right, so that's kind of the idea. All right, so now that we've talked a little bit about that, let's just start motivating kind of the quiz and how we would do this. So I have an example here. All right, so we're gonna, okay, perfect. So got the quiz here. All right, so let's use, I'll just use the code just to kind of give you, I'll create a problem as an example, right? And then after that, we'll do it. And then after that, I will give you the problem and you have to give me M, if that makes sense. Okay. So we're going to switch to the virtual machine for this one. Computing these values, you need code, right? So you won't be able to actually compute these on your own. The challenge is to get D, right? That's the D exponent. Remember, you don't have that. All right, so I'm gonna close. Oh, sorry, not that.